At the end of the last video, I left you with this problem and asked you to work out the division. So I'm going to just rewrite this using long division. So I've got x cubed. I like to fill in that I've got 0x squared, although it's not absolutely necessary that I do that. I do want to make sure I leave a space here, though, because I might get some x squareds as I work through this. And then we're dividing by x minus 2. So we look at our lead terms. X, I would multiply by an x squared to get x cubed. Then I distribute. X squared times x is x cubed. X squared times negative 2, that sign is included, is negative 2x squared. Now we're ready to subtract, which I think of as change the sign and add. The x cubeds cancel, and we've now got a positive 2x squared. I can bring down the next term. Some of you might like to bring down the whole thing. I usually bring down one term at a time, but I remember there's still some stuff up there. So we repeat. We look at our lead term. We say x, I would multiply by a 2x. So I'm going to add 2x to the list of things I'm multiplying by, which I'm writing up here. And then we multiply. 2x times x would give me 2x squared. 2x times negative 2 would give me a negative 4x. And when we subtract, that means we change the sign and add. So the 2x squareds cancel. We always rig it so that that lead term cancels. And now we've got 6x minus 3. So we look at our lead terms. We say x, we would have to multiply by 6. So I'm going to add 6 to the list of things I'm multiplying by. I get 6x here, and then 6 times negative 2 is a minus 12. Subtract, which means change the sign and add. The 6x's cancel. Negative 3 plus 12 is going to be a plus 9. Now, that's my remainder because this is just a constant. It's degree 0, and this is degree 1. So once the degree inside is smaller than the degree outside, we're done. That's our remainder, and we just add the remainder over what we were dividing by. All right. Now, I promised I was going to teach you a shortcut called synthetic division. I will, but I'm actually going to teach it to you using a different example. And I'll confess, the reason I'm doing that is because I'm reshooting this part of the video right now because I made a mistake. When I went to write this as a long division problem, the first time I shot the video, I miscopied it. I miscopied it as x squared. So I did x squared plus 2x minus 3 divided by x minus 2. And I worked that out using long division, and then I taught the shortcut of synthetic division with that example. What I'm going to do is I'm actually going to edit the video so that I can pick up when we were doing this problem, because as I thought about it, I actually like this example better as our first example where we do this thing called synthetic division. And the reason is simply because here we don't skip any powers. We've got a constant, then some x's, then some x squareds. Here we have a constant, some x's. We didn't have any x squareds, and then we had some x cubes. And the second example that we do with synthetic division will be like that, where there's a missing power, and we'll talk about how to do that. But I think it's actually nicer to start with an example where we're not missing a power. So I'm going to go and edit the video so that now you've seen this problem worked out, since I asked you to do that, so we did it together. But then we're going to pick up with this problem, doing it as long division, and then taking a look at synthetic division. So I would look at my lead terms. You'll notice everything's written in descending order. What would I multiply x by to get x squared? X. Multiply. X times x gives me x squared. X times negative 2, don't forget that sign, gives me a negative 2x. We're ready to subtract. That means change the sign and add. So the x squareds cancel out. We get 2x plus 2x is 4x. And then we bring down the 3. So then we look at our lead terms again. We say, what would we multiply x by to get 4x? I'm thinking 4. So I'm going to add 4 to the list of things I'm multiplying by. 4 times x gives me 4x. 4 times negative 2 gives me negative 8. change the sign and add. So the x's cancel out. Negative 3 plus 8 is 5. That's my remainder. Anytime I get down to a number, that's going to be my remainder because that's going to have degree 0, which will be smaller than anything that had x's in it. Here, because what I was dividing by was linear, it was degree 1, we had to get down to something that was just constant as our remainder. So what do I do with that remainder? I add the remainder over x minus 2. So that is my answer. All right, I'm going to show you how synthetic division works for this problem, and then I'll show you how to do it, and we'll talk about why it works. What I'm going to do is I'm going to encode this polynomial by just writing its coefficients. So I had 1 copy of x squared, I had 2 copies of x, and my constant term was negative 3. Now here, I'm not bothering to write in the powers of x, so I know what this is the coefficient for by where I put it. Starting furthest to the right, this would be the constant, then my x to the firsts, then my x squareds. Here, if I were missing a power, I would have to write a 0. Okay? Because otherwise, because I'm not writing the power of x, I wouldn't know what I had. So, going to be very important. Here it's not necessary to write a 0, but if I were missing any powers, it would be. Now, what I'm going to do is I'm going to put what I think of as an upside down multiplication sign. Again, if you learned your long division in a different country, this might be the way you're used to writing it, but I've left some space here because this is going to be part of my workspace, and I'm going to end up putting my answer sort of encoded down here. Now, I'm dividing by x minus 2. Synthetic division is a shortcut that works if I'm dividing by, so synthetic division only works when we're dividing by 1x minus some number. So it's important that I have just 1 copy of x. This has to be degree 1. It has to be a linear thing that I'm dividing by. If I have x squared, synthetic division doesn't work. If I had 2 copies of x, synthetic division doesn't work. So I've got to have 1 copy of x minus a number. Now, we've seen plenty of times that if I'm adding something, I can view that as subtracting a negative. So if I had x plus 2, I'd just view that as x minus negative 2, and we'd be totally fine. Okay, so what we're going to do is we're going to take the number that we're subtracting and write it out here. Essentially what I've done is I've pre-changed the sign. Every time we were ready to subtract, we changed the sign and added to combine our like terms. Well, if I were to multiply by a plus 2 instead of a minus 2, that would do the same thing as changing that sign. Okay. So I'm writing the number that I'm subtracting, essentially changing the sign from what appears in that factor. Now, I'm just going to show you what I do, and then we'll talk about why it works. It starts by I just copy that first number right there. And now, from here on, I'm going to multiply and add. 1 times 2 gives me 2. 2 plus 2 is 4. Now I take this and I multiply. 4 times 2 gives me 8. Negative 3 plus 8 gives me 5. Okay. Why I did that, we'll come back to. Okay. But notice, now that's my answer in code. This last position is my remainder. This is my constant. This is my x's. Notice we got 1x plus 4 plus our remainder was 5, and we write plus our remainder over the divisor, or what we were dividing by. Okay. Kind of a cool technique. Now, you might say this wasn't too bad, I just prefer to do the long division. We're going to be doing lots of it. We're doing enough of it that I think it is worth everyone's time to master the synthetic division. If you prefer long division, you can do it, but I'm warning you right now, you might think today I prefer to just do the long division, I don't want to learn this shortcut. You'll probably regret that. I would encourage you to learn the shortcut. Now let's see why it works. Okay. It works specifically because we have 1x minus a number. Okay. So notice my first coefficient here was 1. Okay. So because I had just 1x, in order to get 1x squared, I multiplied by 1x. Whatever this coefficient is, that's going to be the coefficient of what I multiply by. So the coefficient of that first term matches the coefficient here. Okay. And then when I multiplied, I got x squared minus 2x. That first term canceled out. So I really just cared about what I got right here. And I could see my next term was a 4x. Now I got that by multiplying the x by -2 and then changing the sign and adding. Here, what we did is we multiplied our coefficient of 1 by +2. We'd already changed the sign, so we got 2 and we added. This is what we get when we change the sign. This is what we get when we add. So now that's my new lead term. It has a coefficient of 4. Now because I've got just 1x out here, what am I going to multiply by to get something with a coefficient of 4? Well, it's going to have to be 4. So that's going to be the coefficient of my next term. Okay. All right. And then what we did is we took that 4 and we multiplied. Now, of course, the 4 times x, that was just going to cancel out. What gives me my next part is what I got when I took the 4 times the -2, changed the sign, and added. Well, that's the same as 4 times +2, and just add. Okay. And then that gave us our remainder. So essentially what we're saying is these numbers here are always going to be the coefficient of our lead part every time we're ready to divide. But because I'm dividing by 1 copy of x minus something, whatever the coefficient of my lead term is at that step of the problem, that's going to be the coefficient of the next term in the answer. And so this is a code for constants, x's, x squareds. This is a code for my answer. I just have to remember that this first digit, the one farthest to the right, is the remainder. So this is constants and x's. Pretty cool. Let's try another problem using synthetic division. Let's say I had 2x cubed minus 4x plus 1, and I wanted to divide by x plus 3. So for synthetic division, I'm going to say I've got 2x cubed, 0x squareds, -4x plus 1. Notice here we are missing a power. We don't have any x squareds. I have to write in that 0. If I just wrote 2, -4, 1, I'd say that was constants, that was x's, I had 2x squared. The way I know that that's 2x cubed is because I say constants, x's, x squareds, x cubed. So if you're missing a power, it is absolutely necessary to write in that 0. And then we say x plus 3, that's x minus -3. So we write the number that we're subtracting, or you can think of that as we pre-change the sign. We start by just bringing down the 2, because I know if I'm trying to multiply x by something to get 2x cubed, I'm going to have to multiply by 2. If that's the coefficient of my lead term, that's going to be the coefficient of my first term in the answer. And now we just multiply and add. 2 times 3 gives me -6. 0 plus -6 is -6. -6 times -3 is +18. -4 plus 18 is 14. 14 times -3 is going to be, oh, I can do this, -42. 1 plus negative 42 is negative 41. Now this is code for my answer. That's my remainder. So this is constants, x's, x squareds. So I'm getting 2x squared minus 6x plus 14. And I'm going to add my remainder over what I was dividing by. Now in this case, because there's just one term in the remainder, if you wanted to bump that negative sign to the front and write minus 41 over x plus 2, you could. But do be careful. We've seen sometimes our remainder can have more than one term. And if the first term is negative, you can't pull out that negative and make it apply to the whole thing. The negative would only apply to the first term. So I usually just play it safe and write plus remainder over what I was dividing by. All right, I'm going to give you folks a problem to try before you tune in to the next video. I want you to do this one using, again, synthetic division. Okay, so let's say f of x is 5x to the fourth minus 2x squared plus 1. And I want you to do for me f of x divided by x plus 2. Try that using synthetic division. We'll go over that at the beginning of the next video.